Hello everyone, assalamu alaikum. Welcome to another video. So today we are going to learn about mole calculation. So in our previous video we learned what is mole and how mole is related to molar mass, molar volume and number of particles. So today we are going to use some formula and calculate number of moles, molar volume of gas and mass of substances using that mole idea. So without wasting any more time, let's start. So for mole and molar mass, we're going to use this formula: N equals m divided by m, small m divided by capital M. Here, the small m is the mass of the substance that we are going to use, and the unit will be in gram. And then we are going to use the capital M, which is the molar mass, and we have already seen it in our previous video. So the unit will be gram per mole, and N will be number of moles. So here, if you have two informations out of these three, you can calculate the other one. Let's see some math. So this is our first math. We're asked to calculate number of moles present in 46 grams sodium. So what is the formula we know? We know that N equals m divided by m. So small m divided by capital M. Now it's very important that you make a right column where you're gonna write the information you have in your question. So let's see. We have m, the mass of the substance, which is 46 gram. Then we also know the capital M, which is the molar mass of sodium. Now from the first video, the part 1 of chemical calculation, we know how to calculate molecular mass and then turn it into molar mass. So molar mass of sodium is 23 gram per mole, right? And we do not have N, so we're just going to put a question mark in there. So why do you need to do the right column? Because when you have the right column, it's very clear that what formula to use and what you need to find, right? So let's put the values in our formula and see what happens. So we have M, which is 46. Then we have this M, capital M, which is the molar mass, which is 23. So when you divide, you're going to get 2. So the unit for M is mole. So you can just write mole. So this is how we can just do the right column and see what you need to calculate and find the answers very clearly. So let's move on to our next question. So this is our question number 2, where we are asked to find the molar mass of a substance if 0.5 mole of it has a mass of 16 gram. So first thing that we're going to do is to make the right column and write our information. So we have the mole number given. So N equals 0.5 mole. Then we have been given the mass of the substance, which is 16 gram. And as we know, small m represents the mass of the substance, and we are asked to find the molar mass here. That means we are asked to find the capital M. We don't have it. Let's put this question mark. Now what is the formula we can make out of these three things? The formula that we can make out of these three things is N equals m divided by m. That means small m divided by capital M. So we are asked to find the capital M, which is our molar mass. Let's put the values first. So for N we're going to put 0.5, and for small m we are going to put 16, and for the capital M we're going to put just m because we don't have it. Now let's move sides. So we want the m to be our subject, right? Let's move it to the other side. Now m is divided here. If you put it to the left side, you're going to multiply it. So 0.5 will be multiplied by m, and we are not doing anything with the 16, so 16 stays as it is. So this is 16. Then we want our subject alone. That means we want our m alone, so we have to move 0.5. Now relationship between m and 0.5 is multiplication, so if we move it to the other side, it's going to be divided. So we have 16 divided by 0.5. When you solve it, we're going to get an answer of 32. Now it's the molar mass, so you have to put the unit right, which is gram per mole. So just like that, using the information given in the question and putting them in your equation, you can solve and find the molar mass using the N equals m divided by m formula. Now let's move on to our third question. So this is our third math, where we are asked to find the mass of 0.2 mole of sodium chloride. Now we are given the number of moles, and we are also given the compound. Whenever we are given the compound, we know the molar mass. We know how to find the molecular mass using the periodic table and atomic mass. Then we can just use gram per mole and convert it to molar mass. In our part 1 video of chemical calculation, part 2 video, we actually solved it. You can find it in the description of the of this video. Okay, so let's see what information we have in this question and put it in our right column. First of all, we have the number of moles. So N equals 0.2 mole. We know that N represents mole. and then we have the compound, that means sodium chloride, so we also have the molar mass. For that one, we need to find the molecular mass first. So the atomic mass of sodium is 23, that we can find from the periodic table, of course, and the atomic mass of chlorine is 35.5. Now we have one sodium and one chlorine, so we don't need to multiply it with anything. So when you add them, you're going to get 58.5, and when you put the unit gram per mole, it has just turned into molar mass. And what we don't have is the mass of the substance. Do not mess up here. Whenever you have a compound, you have the molar mass, and the other mass they're asking for is the mass of the compound. So we don't have the small m, so let's put a question mark with this one. Now we know the formula that n equals small m divided by capital M. If you put the values here, for n you're going to put 0.2. You don't have the mass, so it's m only, small m, and we have the molar mass, which is 58.5. Let's put 58.5. Now we want m to be our subject, so we have to remove this 58.5 from this side to bring it to this side. So the relationship here is division, so if we move 58.5 to the other side, it's going to be multiplied. So 0.2 will be multiplied with 58.5. Remember, we did not move m, so m stays there. Now if you multiply them, let's just switch the side. So m equals, when you multiply them, you're going to get 11.2, and this is the mass of substance. If you remember, the unit will be gram. So let's put the gram only. So just like that, just looking at the right column and using the formula, you can find this one. So with this formula, we have learned how to find number of moles, how to find molar mass, and also how to find mass of substances. Now let's move on to our next topic, which is the relationship between mole and molar volume and how we can use them to calculate some maths. Okay, so just for a small recap, that molar volume is only applicable for gas. So if the substance is solid or a liquid, we're not going to use this formula. So the formula we're going to use to relate mole and molar volume is n equals V divided by 24. So here n obviously means that number of moles, or mole number we can say, and our V is the volume. V is the volume. Now remember, this 24, if you remember about the molar volume thing, 24 is dm cube, so the volume must be also in dm cube unit. Okay, if sometimes it is given a centimeter cube, we have to convert it to dm cube, because this 24 is dm cube. As this is dm cube, we have to convert the volume to dm cube too. So now let's see how the questions are and how we can solve them using this formula. So let's look at the first math using that formula. So we have the question as calculate the number of moles present in 12 dm cube of oxygen gas. Now let's see what information we have. We are asked to calculate the number of moles. That means we don't have n, put a question mark. Do we have V? We have V, which is 12 dm cube. Now we are going to check two things here. First of all, which one is given and what is the unit? See, the dm unit is in dm cube, and we are going to use 24 dm cube, so it's fine. We don't need to do anything else. This is pretty simple. We know that formula is n equals V divided by 24, and we don't know the value of n, so it stays there, and we have the V, which is 12 divided by 24. Just like that, when you calculate it, you're going to get the n equals to 0.5 mole. So it's pretty straightforward. You have a constant here, 24 is not going to change, so you just need one of these things and you can calculate the other one. So just like that, you do the right column, you get your information there and put it in the formula, and you have your answer. This is how you can use this formula to calculate the number of moles of a gas. Okay, now let's see another math where we'll see how we can calculate the volume. So in our next math, we are asked to calculate the volume of 0.1 mole of hydrogen gas. Now again, right column, what information we have? Information we have is 0.1 mole. That means we are given the mole number, so the value of n is 0.1. We are asked to find volume, so V. Now what is the formula we know? We know that n equals V divided by 24, and 24 is in dm cube, so n equals V divided by 24. We are asked to find V, so we will put the value of n, which is 0.1, equals V divided by 24. So V must be the subject, so we have to move 24. Now 24 and V is divided, so if we move the 24 to the other side, it's going to be multiplied. So 0.1 will be multiplied by 24 equals to V. If you multiply them, V equals, you're going to get 2.4 dm cube. Remember, the unit of 24 is dm cube, so your answer of V must come in dm cube unit too. So now let's see another math. If the unit of volume is given in centimeter cube, how we can solve them. In our question 3, we are asked to find the number of moles in 200 centimeter cube of ammonia gas. This is exactly the same thing, but now that we have a problem, the unit is not dm cube, the unit is centimeter cube. Let's see how we can solve it. First of all, information. So we have V, which is 200 centimeter cube. Now we know that the 24 that we're going to use in our formula, which is N equals V divided by 24, this 24 is dm cube. So we have to convert this centimeter cube to dm cube. So how can I do that? You simply have to divide the centimeter cube by 1000, and when you have divided the centimeter cube by 1000, it will be converted to a dm cube. Now that you have your value, which is 0.2, you can divide. So now your centimeter cube is converted to dm cube. Then you can use it straight here, as you have been asked to calculate N. So let's see how we can do that. So you have N equals V divided by 24. You don't have N equals, but you have V, which is 0.2 divided by 24. If you use a calculator and divide it, you're going to get 0.008333 like this. Okay, so this much of mole. So now you see that if your volume is given in centimeter cube, first of all you have to convert it to dm cube, then you can use the formula, because this 24 is in dm cube unit. Now I guess all the things that we can cover from mole and molar volume with this formula has been done. So let's move on to our next section, where we're going to discuss how we can use a formula for mole and number of particles and solve maths. For mole and number of particles, we can also use another formula, which is N equals capital N divided by Na. As we already know from the previous video that Na actually refers to the Avogadro number. So the number is 6.023 into 10 power 23. Now the capital N without the A will show us the number of particles, how many atoms are there or how many molecules are there, this kind of thing. And N, as usual, is number of moles. So you have to, you don't need to memorize this thing, as this is already normally given in your IGCSE question paper. So you'll have this number, then you have to use it here. It's also fixed, just like 24, this number is also fixed, so you don't need to worry about this thing. If you have one of these informations, you can calculate the other. So let's see some maths. So this is our math number 1, where we are asked to calculate the number of atoms in 0.2 mole of sodium. So what are you going to do first? Obviously, our right column. So what do we have? We have number of moles, which is 0.2. So we have the N, small n. So this is 0.2 mole. And we have a constant here, that means Avogadro number that we already know. So you're going to write it 6.023 into 10 power 23. And lastly, we are asked to calculate the number of atoms. Number of atoms, that means number of particles. So which is capital N? We don't have it. Now let's write the formula and put our values in there. So N equals N divided by Na. That was our formula. Now value of N is given, which is 0.2, and value of N we don't know, we have to calculate. Now Na is known, so 6.023 in 10 power 23. That is the number, Avogadro number. Now we want to make N the subject, so we have to move this one, and this one, and this one is divided. So we have to move the whole number to the left side, and it will be multiplied as this one was divided previously. So 0.2 will be multiplied by 6.023 and 10 power 23, which will be equals to our capital N. So now if you just switch sides, so N equals, if you multiply them, you're going to get 3.011 multiplied by 10 to the power 23, and you are calculating atoms, so this will be atoms. So just like that, using the formula and the information, we can easily find the number of atoms or molecules in a equation. But next one, so let's see another compound in there, another substance in there, and find the number of atoms from that question. So let's move on to our question number 2. This is our math number 2, where we are asked to calculate the number of atoms in 0.5 mole of oxygen gas. Now this is not going to be as straightforward as the previous one, but let's calculate what we have first. So right column we have 0.5 mole, so let's write it. So n equals 0.5 mole, and we know the Avogadro number, which is Na 6.023 10 power 23. Okay, so that's it. Now we are asked to calculate n. Now this n is different. Let's see how it is. So we know that n equals n divided by Na, right? So let's put the values. We have the value. So n equals 0.5. This capital is there. The Avogadro number 6.023 to 10 power 23. Then we can multiply to find n, right? So 0.5 multiplied by 6.023 into 10 power 23 equals to capital N. When you find it, n equals, you are going to get 1.2044 to 10 power 24. Now, what did you actually find? Did you find number of atoms? No, you did not find number of atoms, because you see this oxygen here, this oxygen is not an atom, it's a molecule. That means you actually found the number of molecules, right? This oxygen is not an atom. Just O is an oxygen atom, O2 is the oxygen molecule. So you did not find number of atoms, you actually found number of molecules. So this is the number of molecule. Now how can you find number of atoms? Look at them. In an oxygen molecule, we have actually two oxygen atoms. So in each oxygen molecule you have two oxygen atoms, like a double oxygen atom. So if you multiply the number of molecules by 2, you are going to get the number of atoms, right? Again, in each of oxygen molecule you have two oxygen atoms. So in this much of molecules you will have double of oxygen atoms, right? So number of oxygen atoms will be the number you found, 1.2044 multiplied by 10 power 24, and it will be multiplied by 2. Again, why? Because in one oxygen molecule you have two oxygen atoms. So in this much of oxygen molecule you have multiplied by 2, double oxygen atoms. When you multiply it, you're going to get 2.4088 to 10 power 24 atoms. So this is how you solve it. So when you get a question like this, be careful about the symbol given. If they're asking for atoms but the symbol is molecule, you remember you have to use the ratio to find the number of atoms. Simply you have to multiply with the number here. That means the number of atoms you're using to form the molecule. First of all, you find the number of molecules and multiply the number of molecules with that number. You will have your number of atoms. I think it is clear now. Now, what we're going to see now is how, if we combine the formulas, we'll learn 3 formula. Can we combine the formula and can we solve some other maths that we cannot solve directly with one formula only? We might need to solve using two formulas. Okay, so let's see them. So we have our first question of combined maths. Let's see what we can do. The question is, find the mass of 12 dm cube of oxygen gas. What are we asked to find? The mass. That means we are trying to find the mass of the oxygen gas. So let's see what we can put in our right column. So we have the volumes, that means V, 12 dm cube. But then we are being asked to find the mass, that means small m. We don't have it. As I said, whenever you have the compound, you have the molecular mass, right? That means molar mass. So m. One of the atoms mass is 16 and you have 2 atoms in this oxygen, so you have 32. When you put gram per mole, it has been converted to molar mass. Now, what is the formula we know to calculate mass of a substance? Yeah, we know that n equals small m divided by capital M. How can you do that? We can just put the values and find them there. What is the problem here? The problem here is we do have the m, which is 32, but we don't have n. We don't have number of moles. Now we have two unknown here. We have small m, which is unknown, we are trying to find, and we are also trying, we don't have n, so we cannot actually use this formula to calculate m. What are you going to do? You are going to use the other information given here to find your unknown and put it here and calculate your main thing. So let's see what we know about the v. We know that n equals v divided by 24, right? So if you put values, the value of v is 12 and value of 24 is 24, which is given, right? So now we have the value of n, which is 0.5. Now we're going to take this 0.5 and put it here. So let's put it here. Now we have n 0.5. We're trying to find m. M is there, and the molar mass is given, which is 32. Now let's move this 32 to the other side. We know that it will be multiplied. So 0.5 multiplied by 32. Now we have small m. Switch sides, we have m equals 16, and as we are trying to find the mass of the substance, it will be gram. See, we could not solve the math directly using n equals m by m, but we use the other information given in the question to find n and bring that n to here, put the value, and then you could find the value of m. This is how, even if you cannot directly use the formula, you can use the other information and solve the maths. Now let's see another math just like this one. So this is our second math of our combined maths. Let's see the question. We have find the number of atoms present in 2.8 gram of nitrogen gas. As usual, we are going to write our right column first. That means the information column. What do we have? We don't have number of atoms, so we are basically being asked to find the capital N. We don't have it. 2.8 gram, that means we have been given the mass of the substance, which is 2.8 gram, and we have nitrogen. Whenever we have the compound, we have molar mass, which is m, capital M. And we have two nitrogens. Mass of one nitrogen atom is 14, mass of two nitrogen atom is multiplied by 2, so we are going to have 28 gram per mole. So this is the information we have already. Now what is the formula we know to calculate number of particles? We know the formula to calculate the number of particles is small n divided equals to capital N divided by Na, which is 6.023 into 10 power 23, right? Basically we also have that information, Na, so 6.023 multiplied by 10 power 23. Okay, but if we want to calculate n, number of particles, directly, we cannot do that. Again, we don't have n. So how can we do that? We can do it in the other portion, find the value of n, bring it here, and then calculate n. Can we do it? Yes, we can do it, because we have m, small m, mass of the substance, and we also have the capital M, molar mass. Now we know another formula, that n equals mass of the substance divided by the molar mass. If we can use it, we can find the n, and we can use this n here and calculate our number of particles, right? So let's do it. So this n here is, I don't know, so m is here 2.8 divided by 28, so you are basically going to get n equals 0.1 mole. Now that you have the value of the mole, put it here. So you have 0.1 equals number of particles that we don't know, divided by Avogadro number 6.023 10 power 23. Now obviously we want n as our subject, so we have to move this thing. It is divided, so if it comes to the left side, it's going to be multiplied. So 0.1 multiplied by 6.023 into 10 power 23 equals our capital N. Let's just erase it. So n. Now let's switch sides. N equals, we'll have 6.023. You can multiply this with a calculator and gonna find the result. 10 power 22. So here you go, you have found your n, number of particles. Now again, what is the particle? What did you find? Did you find atom or molecule? Again, go back there. Nitrogen is a diatomic molecule. That means two atoms make one molecule. So you actually found number of molecules, not number of particles, number of atoms. Okay, if you want to go to number of atoms, what do you need to do? Number of atoms, you need to multiply that number with 2, because one nitrogen molecule has two atoms, so this number of nitrogen molecules will have multiplied by two atoms. So 6.023 to 10 power 23, then you'll have to multiply it by 2. So whatever the result you find here is the number of atoms in your 2.8 gram of nitrogen gas. So this is how, even if your direct formula is not working, you can use the other formula, other information to find missing information, use the missing information in the direct formula, and then find your result. I guess whatever calculation you need to do with moles, it's very clear now. If you have any question, you can ask me question in the comment section. We will see you in the next video. In our next video, we're going to learn limiting reactant, which is the very first step to go to reactions. Okay, so stay tuned. Thank you for watching this video.